Now here plus what will be the integrating constant here? In ordinary derivatives, we used to write some C1 or C2 something number you used to write, right?
Sir, they
So
divided
here,
by 2x plus 3y, sir.
huh? No, divided by, it
Sine
is not
2x.
A. Wait a minute. Divided by 2, you will get. X quotient is 2. So that's why I had to write only 2. Okay. Plus, here y is constant, right? While we are integrating with respect to y, sorry, with respect to x, other variable we have to treat it as constant. Okay. So plus what will be the integrating constant here other than x? So that means here you can take f of y as integrating constant, function of y as integrating constant. Clear? So now again integrate on both sides. Integrate with respect to x on both sides. So what happens? So again one more derivative will vanish. Dou z by dou y is equal to integration, that means 1 by 2 I'll keep outside, integral sine 2x plus 3y dx plus integral f of y dx. Correct. Now dou z by dou y is equal to 1 by 2. Okay. Integration of sine ax. How much?
minus cos 2x plus 3y divided by 2, sir.
Plus 3y divided by 2. Okay. Plus f of y is constant. Okay. Into integration dx. Integration 1 dx.
X.
We'll get x. Okay. Again plus integrating constant you have to write. You can write this time as plus g of x. Okay. So overall I'll write again dou z by dou y is equal to minus 1 by 4 cos of 2x plus 3y. Okay. Plus x into f of y plus g of x. Is it fine? Now finally one more derivative with respect to y is there. So if you want to vanish that y, we need to integrate on both side again. Again integrate with respect to y on both sides. Okay. So if you integrate with respect to y on both sides, what happens? Let us see. So now that derivative will get vanished, only letter z will be there. So that is our required solution, where z equal to minus 1 by 4. Okay, integration of cos. So integration of cos 2x plus 3y dy. Okay, next plus x into integral f of y dy plus integral g of x dy. Okay, so finally z is equal to minus 1 by 4 integration of cos 2x plus 3y. How much? This is nothing but sine 2x plus 3y divided by how much?
3.
So divided by 3 plus x into integral f of y dy. I'll keep as it is, plus we don't know about f of y, so we have to keep as it is. So integral g of x. So g of x is constant. Integral dy. So integral 1 dy value is y. Okay. Plus what will be the integrating constant this time? Sorry, here instead of d of x, it is dy. Okay. So integral g of y dy will get it. Because here we are integrating with respect to x. Opposite variable we have to treat it as integrating constant. So that means g of y is constant. So z is equal to minus 1 by 12 sine of 2x plus 3y plus x into, so this is also some function of y. So this I am treating it as capital F of y, where f of y is arbitrary constant. Similarly, this I can write it as g of y, capital G of y, where g is a function of y. Okay, so we don't know about that function exactly, so we are making it as arbitrary function. Okay, so this is the required solution which we want by direct integration, where f of g and f of y and g of y are arbitrary constants or arbitrary functions. Plus here one more integrating constant with respect to y we have to do, right? What is it? Plus h of opposite variable. That means h of x we have to write. That's it. Fine. So here also you have to write plus h of x. Now let us see this. Solution. So here he asked us to solve dou square z by dou x dou y is equal to sin x sin y, for which the condition dou z by dou y equal to minus 2 sin y when x equal to 0 and z equal to 0 if y is an odd multiple of pi. Okay, so that means he has given two conditions, because since we know that we are going to integrate for twice. So when you are integrating for twice, you will get two arbitrary constants. So to find the two arbitrary constants, he has given two conditions. So using these conditions, we are going to solve arbitrary constants also or arbitrary functions also. Okay, so let us see. The procedure is same like previous problem. So let us write given dou square zy dou x dou y is equal to sin x sin y. Okay, implies if you want to integrate, first split it and write dou by dou x of dou z by dou y. Correct. So the meaning of this is nothing but this: sin x sin y. Now integrate with respect to x. So if you integrate with respect to x, this derivative will vanish. So that means dou z by dou y is equal to, so we are integrating with respect to x. So that means sin y is constant. So sin y I am keeping outside, integral sin x dx. Okay. So dou z by dou y is equal to sin y into integration sin x minus cos x plus integrating constant. Whether we are integrating with respect to x or y. If it is x, function in terms of y, we have to treat it as constant. Okay. So now integrate with respect to y on both sides. Okay, if you integrate with respect to y on both sides, what is then? Z is equal to minus cos x. You have to treat it as constant, integral sin y dy plus integral f of y dy plus, here I can take g of x as constant. Okay, so because you are integrating with respect to y, you have to take opposite variable or other variable as arbitrary function. Okay, so z is equal to minus cos x into integration of sin y minus cos y plus f of y. So this I can treat it as function of y. So I am writing it as capital F of y plus here g of x. So I will keep that g of x as it is. Now we need to find what is this capital of f of y and similarly g of x. Okay. So to find this, what they have given conditions. Or what are those? Dou z by dou y is equal to minus 2 sin y. Okay. Comma x equal to 0 you have to take. Okay. So suppose if I take this equation as 1 and this equation as 2. Okay. In equation 2 we are having dou z by dou y. Correct. So from equation 2, okay, I am substituting this value from equation 2 on the left hand side. What happens? Minus sin y cos x. Okay, sin y cos x plus f of y is equal to, on right hand side we are having 2 sin y. So on the left hand side at x equal to 0 we have to take. Okay, since they have given two conditions at a time. So we have to take x equal to 0. We have dou z by dou y value is minus 2 sin y. Okay, now substitute x equal to 0 in this equation. Cos 0, how much? So I'll get 1. Okay, so minus sin y plus f of y is equal to 2 sin y. Okay, implies what will be f of y from this? Here minus sin y, if you send it to right hand side, you get a plus sin y. So 2 plus 3. So that means 2 plus 1, it is 3.
Sir,
So
it should be
3
minus
sin
2
y.
sin y, no, sir. Minus
Huh?
2 sin y, no, sir.
Sorry, it is minus 2
Right hand.
sin y. Okay. This is minus 2 sin y. Okay. Oh, minus 2 sin y. So at that time what happens? You'll get minus sin y as your f of y. Now in the final solution, what we are having? Integral of f of y. So integral of f of y is how much? Minus integral sin y is equal to how much?
Cos y.
Minus of minus cos y,
Minus.
because integration of sin y is minus cos y. So cos y. Okay. So finally this integral f of y is called as your capital F of y, which is equal to cos y. Okay, one arbitrary function we have found. Okay, so take this solution as equation 3. Take this one as equation 4. Now, using the condition, okay, so one more condition he has given. Z value will be 0 if y is an odd multiple of pi by 2. Okay, so that means the condition is z is equal to 0 when y must be odd multiple. Odd multiple I can write it as 2n plus 1 pi by 2. Okay, so 2n plus 1 represents an odd number. Okay, so substituting these conditions in equation 3. So from equation 3, so what is that equation 3? Z is equal to this much. Correct. So on left hand side substitute 0. So 0 equal to minus of minus, you'll get plus cos x into cos y plus f of y, so capital F of y plus g of x. Okay, this function at y is equal to 2n plus 1 pi into pi by 2. Okay, so substitute y value as 2n plus 1 pi by 2 in this equation. So 0 equal to cos x cos of 2n plus 1 into pi by 2 plus, so f of y is nothing but cos of 2n plus 1 by 2n plus 1 into pi by 2 plus g of x. Okay. So what is an odd multiple of pi by 2 for cos? How much? Cos pi by 2 is how much?
1.
Cos pi by 2.
0, sir.
So 0, right? So whether it may be even or odd. Okay. Sorry. For all odd multiples of pi by 2, so you'll get 0 as the answer. What happens if we get quotient as even? So 2 will get cancelled, right? So at that time it may take plus or minus. So we are taking only odd multiple. So therefore 0 is equal to first term, this one we are getting 0, second term we are getting 0 plus g of x. Why we are taking? Since cos 2n plus 1 into pi by 2 value is 0. Fine. So we got g of x is equal to 0. Okay. So even in this equation you can write from equation 4. From equation 4 we have substituted f of y value. Clear? So take it as equation 5. Substituting equation 4 and 5 in equation 3. What happens? Z is equal to, substitute arbitrary function values. Z is equal to cos x into cos y plus cos y plus 0. So z is equal to, you can take cos y common, 1 plus cos x or cos x plus 1 is the solution. So with the given conditions we have found the solution for given partial differential equation. Okay, I'll do one more last problem based on this, and one problem I'll give you for homework. Just check it once. Okay, this problem I'll do, and this problem I'll give it as homework. So let us check out this question. Here solve this equation, okay, subject to the conditions that dou z by dou x equal to log of 1 plus x, okay, sorry, 1 plus y when x equal to 0 and z equal to 0 when x equal to 0. Okay, so first condition is take x equal to 1 and equate dou z by dou x as log of 1 plus y. Similarly, take x equal to 0 when z equal to 0. Okay, so let us solve this equation. First we will find dou square z by dou x square. That means second derivative of x with respect to x. So xy is there. Now this can be written as dou by dou x of dou z by dou x. So I have splitted the integral. So I have splitted the derivative. Okay. So now integrate with respect to x on both sides. Okay, if you integrate with respect to x on both sides, what happens? Dou z by dou x is equal to y is constant integral x dx. Okay, plus otherwise I'll write in the next step. So dou z by dou x is equal to y integral x, that means x square by 2
Plus f of
plus f of y is integrating constant. Okay, so now again integrate with respect to x on both sides. Okay, so integrate with respect to x, you will get finally z is equal to half y into integral x square dx plus integral f of y plus g of y. Okay, so z is equal to half y into x cube by 3 plus this I am taking it as capital F of y plus g of y. Okay, so I am taking the given equation as equation 1 and dou z by dou x, I got this, so I have taken this as equation 2 and this as equation 3. Okay, so using the given condition, using the condition dou z by dou x is equal to log of 1 plus y at x equal to 1. Okay, so substitute x equal to 1 in equation 2. Okay, so from equation 2, so dou z by dou x is how much? Y x square divided by 2 plus f of y. Take x equal to 1 in this equation is equal to right hand side, he has given that log of 1 plus y. Okay, substitute x equal to 1, y by 2 plus f of y is equal to log of 1 plus y. So implies f of y will be how much? Log 1 y minus y by 2. Fine. So we got arbitrary function f of y. But in the equation 3 we have integration of f of y is there. So integration of f of y will do. Integration of f of y is equal to how much? Integral log of 1 plus y minus dy minus 1 by 2 integral y dy. So integral f of y is equal to integration of log x.
power 1 plus x.
Oh, sorry. Here, I think we did some mistake. Here, integration with respect to x we did, right? So, whenever you are doing integration with respect to x, this is x into f of y. Okay. So, no need to do integration for this. So, this is not necessary. Okay. So, we have found f of y. So, substitute f of y directly there. Next, using second condition. Using the condition z is equal to 0, comma x equal to 0. So from equation 3, okay, put z equal to 0. So left hand side it is 0 is equal to x equal to 0 we have to substitute. That means 1 by 6 y into 0 plus 0 into f of y plus g of y. Okay, so all terms become 0, g of y is also 0. So take it as equation 5 and take this as equation 4. Now substitute equation 4 and 5 in equation 3. So finally z is equal to how much? X cube y divided by 6 plus x into f of y, x into log of 1 plus y minus xy by 2 plus g of y, plus g of y is 0. So I can take plus 0. So finally the required solution z is equal to x cube y by 6 plus x log 1 plus y minus xy divided by 2. Fine.